Alrighty, so last video we talked about improper integrals of type 1. And in this video I want to talk a little bit about improper integrals of type 2. So I've got down here an integral that I evaluated, and it's a pretty simple one, dx over x squared from -1 to 1. Let's get that in there right, -1 to 1. But the thing is, there is something really horribly wrong with this integral. And I just want to emphasize this. There is something horribly, horribly wrong with this integral. This is not correct. So if you're watching this, don't look at it and go, oh, this is how you do this. This is not correct. Let's see if we can figure out what the issue is. So I go through. And I rewrite, excuse me, dx over x squared is x to the -2 dx, right? Okay, so it's a power function. So add 1 to -2, that's -1, divide by -1. So I get minus x to the -1, evaluate it from -1 to 1. Plugging in the top one, that's going to be -1 over 1. Plugging in the bottom one is -1 over -1, and you're subtracting that, so you get, well, that becomes 1, right? -1 minus 1, that's -2. Okay, so we get an integral of -2. Now, before we even figure out what's wrong, one way we can tell there's something drastically wrong here is because if I look at the graph of y equal 1 over x squared, well, first off, it's entirely above the x-axis, right? Well, even if you don't know what the graph of 1 over x squared is, you know that x squared is always positive. So 1 over x squared is entirely above the x-axis. So if I'm going from -1 to 1, first off, I should not get a negative number. But looking at this graph may give you a hint of what else is wrong here. What else is wrong? Yeah, it's not even defined at 0. Not defined, more to the point, it's not continuous. The integrand itself, 1 over x squared, is not continuous at x equals 0. That is where the issue is. The fundamental theorem of calculus says if the integrand is continuous over the interval, then we can evaluate the integral by finding the antiderivative and plugging in the endpoint. So this equal sign here is the one that's wrong because you cannot use the fundamental theorem of calculus because the thing is not continuous, because 1 over x squared not continuous at x equals 0. That's where the issue is. So type 2 improper integrals are an attempt to, or they kind of add some meaning to how do we deal with things that are not continuous. Okay, and just like with the type 1, there are going to be 3 types of type 2. This one that we looked at out here with the issue is the third type. So let's look at the first type here. I mean the first case in the type 2 ones. In the type 2, not the type 1, the type 2 ones. So the first case is f is continuous on the half open interval from a to b, but not continuous at b. In that case, we can define the integral from a to b of f of x dx to be the limit as t goes to b from the negative side. So what we're doing is we're getting a little bit short of that discontinuity, right? So t is a little bit less than b. So it's going to be continuous on the interval from a to b, t. And it's, so if we look at the integral from a to t of f of x dx, f of x will be continuous on the interval from a to t if t is a little bit less than b. And then if I take the limit of what I get when I evaluate that integral, that's going to be the integral from a to b. That's if that limit is finite. Otherwise we say the integral diverges. In this case, we say it converges. If the limit's finite, we say it converges. So we've got a word for that too. But it converges to whatever that finite number is. And it diverges if that limit is not finite or if it just simply doesn't exist. Okay, that's a B. That's diverges. So sorry. Okay, so what's the second situation you can have? Well, you got a half open interval on the open on the right. You can have it open on the left as well. So the interval from A to B, open, closed on the right, open on the left. So f is continuous on that, but not continuous at A. Then we define this integral from A to B of f of x dx. Any guesses? You can probably extrapolate. It's going to be a limit. It's going to be a limit as t goes to A from above. So we're taking t a little bit bigger than A. So in other words, it's going to be continuous on the closed interval from t to b, the integrand is. And so we can evaluate that integral. And again, the same conditional here applies over here too. If that limit is finite, and otherwise we say it diverges. And finally, there's one other case. F is discontinuous at some point C between A and B. In this case, we say the integral from A to B of f of x dx is equal to the integral from A to C of f of x dx plus the integrals from C to B of f of x dx. If both those intervals on the right converge. And again, otherwise we say it diverges. Okay, so what does that mean to us above up here? Well, let's see if we can find some space. Let's do this in a green. Okay, so let's actually try to figure out whether or not this thing here, this interval that we looked at, converges. Well, if it converges, what we have to do is break it up into the integral from -1 to 0 of dx over x squared plus the integral from 0 to 1 of dx over x squared. Because 0 is the place where you have discontinuity, and if both of these intervals converge, then this interval converges to the sum of those two. However, as it turns out, neither of them converge. Let's just look at one of them, okay? Let's look at the integral from 0 to 1 of dx over x squared. That's going to be the limit as t goes to 0 from the positive side, right? Because 0 is the discontinuity of the integral from t to 1 of dx over x squared, which is the limit as t goes to 0 from the positive side of -1 over t, evaluated from t to 1. Sorry, that's -1 over x evaluated from t to 1, which is the limit as t goes to 0 from the positive side of -1 minus -1 over t, so that's +1 over t, And what happens to 1 over t? Well, that's of the form 1 over 0. That goes to infinity, right? So negative 1 plus, that goes to infinity. So this limit is an infinite. Eek! It diverges. That means this thing here diverges. That original integral that we looked at diverges. It's not equal to negative 2. It diverges. And this is a good place to stop.